Okay, I wanted to follow up Monday's class with just a short video so you can more easily complete the homework. Actually, didn't get to as much as I wanted to. So we left off class with a task that I had you do, and that was to find the cosine of pi over 6. So, like we did earlier in class, you can do that by making this right triangle, and the hypotenuse of that triangle is the radius of the circle, which is 1, because this circle is based on, it's the unit circle, that's the point 1, 0. So every radii will have a length of 1. And I told you that the sine was truly exactly 1/2. So I gave you that piece of information, and I said, find the cosine of pi over 6, which that value would be the length of the base of this triangle, because that length is the same as the horizontal distance to the right of the vertical diameter in a fraction of a radius. So we can define what that is. We can just call that, say, x, like an x coordinate. And we can do x squared plus 1/2 squared equals 1 squared. The Pythagorean theorem on that right triangle. And when you do the math, x squared plus 1/4 equals 1. X squared equals 3/4. And so then x equals the square root of, it would be plus or minus, but we know we've got a length, so that's just going to be the positive version of the square root, which simplifies to radical 3 over 2. When you get an approximation for that, you see that's 0.866, and we had originally predicted this was about 0.85 just by looking at it, by looking and seeing what that cosine was, about 0.85. It's truly 0.866, and then on and on and on. Exactly radical 3 over 2. So that's the sine and cosine of pi over 6. Radical 3 over 2 and 1/2. Now if we look at pi over 3, we see that this is really kind of it's really a congruent triangle here to this one, because pi over 6 and pi over 3 break up this first quadrant exactly into thirds. We really have the kind of symmetric situation to pi over 6. It's now, except now the sine and cosine are reversed. We see that our cosine, or our x-coordinate here, is 0.5, and our sine is this, here's this, looks like that prediction again would be 0.85, and indeed it's that same value, radical 3 over 2, which we could find by this hypotenuse is 1, the cosine here, this base here, is 1/2. Same exact calculations here would result in the sine now of radical 3 over 2. Okay, so that gives us the sine and cosine of these three key angles in the first quadrant. So let's show those. So we said that pi over 6 had a cosine of radical 3 over 2, or about 0.866, and a sine of exactly 1/2. Pi over 4, both the sine and the cosine are radical 2 over 2, which we showed earlier in class, or about 0.7. 0.7 of a radius length. And finally, at pi over 3, our cosine is 1/2 of a radius length, and the sine is this 0.866, or radical 3 over 2 to be exact. So these are cosine and sines of pi over 6, pi over 4, and pi over 3. But what happens is, because of the symmetry, I'm showing these rectangles here to show that by symmetry, all of the key angles then, if I include here 1, 0, for an angle of 0, and 0, 1 for an angle of pi over 2, then all of these angles then in the rest of the quadrants, 2, 3, and 4, can be found by symmetry, by having the same x and y coordinates as these. It's just a matter of applying the right positive or negative. Okay, so for example, I've got some questions down here that I was intended to ask you. What's the cosine of 5 pi over 6? So we come here to 5 pi over 6. Cosine, we know we want the x-coordinate, or the horizontal distance to the right. And so we're looking here, and, well, it's just the reflection of this length here, which we know is our radical 3 over 2. But since we're to the left of the vertical diameter, it'll be negative square root of 3 over 2. Okay, what's the sine of 11 pi over 6? So here's 11 pi over 6. The sine will be the vertical distance above the horizontal diameter. So it'll be this right here, and that will be negative value because we're below. But by symmetry, we see that will be the same magnitude as the sine of pi over 6, which we saw was 1/2. So instead of positive 1/2 as the sine of pi over 6, it'll just simply be negative 1/2, the same distance down to this point on the circle as this was up. Okay, what's the cosine of 5 pi over 3? Cosine of 5 pi over 3, well, that's taking us to here. So we want the x-coordinate, or how far we are to the right of the vertical diameter. Well, we see that by symmetry, that's going to be the same as our cosine of pi over 3, which is 1/2. So both the angle of pi over 3 and 5 pi over 3 both have a cosine of 1/2, or half a radius length, to the right of the vertical diameter. Okay, what's the sine of pi? The sine of pi, here we are at pi radians. The sine is the vertical distance above the horizontal diameter. Well, pi, that point on the circle is on the horizontal diameter, so our vertical distance would be 0. Okay, what's the cosine of 3 pi over 4? Right here. So we want the horizontal distance to the right of the vertical diameter, or we want this distance right here, which we see by symmetry would be the same as that distance right there. So we can use the cosine of pi over 4, radical 2 over 2, and apply the negative, because now we're to the left. What's the sine of 2 pi over 3? So the sine of 2 pi over 3 would be, here we are, 2 pi over 3. The sine would be this vertical distance right here, which would be the same vertical distance as for pi over 3. So we're going to apply the sine of pi over 3 to get the sine of 2 pi over 3, and it will still be positive because it's above the horizontal diameter. And the sine of pi over 3 is radical 3 over 2. Okay, what sine of, for the sine of 1/2, we're looking at a vertical distance above the horizontal diameter of 1/2 radius length, right? 1/2 radius length, or that fraction of a radius. And we see for sure that this angle pi over 6 has a y-coordinate of 1/2. But then if you notice, come over here to 5 pi over 6. So given a vertical distance above the horizontal diameter, there's often 2 points that will have that sign. So that gives us 2 angles, pi over 6 and 5 pi over 6. But if we think about it, if we rotate a full angle of openness of 2 pi and then add another pi over 6 to that, that likewise would have a sine of 1/2, or 2 pi plus 5 pi over 6 would also have a sine of 1/2. So really, we want any number of rotations. So if k is any number of rotations, and that could be any integer, positive or negative, and then plus pi over 6. Or 2 pi k plus 5 pi over 6. And this is k is any integer. So we're going to go k times around the circle in either direction. So we could go, k could be positive, or k could be negative. We could go clockwise around the circle. And this will always take us back to this 3 o'clock position. If we add pi over 6 from there, we get an angle whose sine is 1/2. Similarly, we go any number of rotations around the circle in either direction. If we add 5 pi over 6, we're going to get this point on the circle, which has the sine of 1/2. So there's an infinite number of angles. From 0 to 2 pi, there's 2 angles, pi over 6 and 5 pi over 6, between 0 and 2 pi. But if we're allowed any real number for the angle, then there's an infinite number of angles that have a sine of 2 pi. Okay. Similarly, what angles give a cosine of negative 1/2? So a cosine of negative 1/2 cosine of negative 1/2 would occur here, where we're 1/2 unit to the left of the vertical diameter for the negative. There we go. So here we are, 1/2 unit to the left of the vertical diameter. And again, same situation, we have 2 points. If we wanted an angle between 0 and 2 pi, 2 pi over 3 and 4 pi over 3 would be the 2 angles that would have a cosine of negative 1/2. But if we allowed any real number to be our angle, then again we could have any number of rotations, positive or negative, and then or any number of rotations, positive or negative, plus 4 pi over 3. So for k, for any integer, we'll always get a point, an angle that gives us a point right here on the circle with a cosine of 1/2. Similarly, this down here would always give us an angle that had a terminal point right there. And the cosine would be negative 1/2. So here's some more practice for you, and then what angle gives a cosine of radical 3 over 2, and solve sine of theta equals negative radical 2 over 2 for theta, similar type questions. But the idea is that knowing these coordinates here in the first quadrant, because of the symmetry of all these angles that we found, the 16 key angles, because of the symmetry, we now know the coordinates of every point for the 16 key angles on the circle just by applying the right positive or negative, knowing that sine is positive when you go above the horizontal diameter, sine is negative when you go below, cosine is positive when you go to the right of the vertical diameter, and cosine is negative when you go to the left of the vertical diameter. So that then, knowing these coordinates, knowing these angles, allows you to write the sine and cosine of all 16 key angles on the circle. And we'll pick it up here on Wednesday.